5 steps to optimization problems. The first step is to draw a picture. The second step is to find the formula that has to be maximized or minimized. The third step is to eliminate variables and express the quantity to be maximized or minimized as a function of one variable. The fourth step is to find the domain, and the fifth step is to use sign analysis. The question is asking us to find the radius and height of a cylinder inscribed in a cone that has the maximum volume. The height of the cone is 10 inches and the radius is 6 inches. To find the radius and height of the cylinder with the maximum volume, we must take the derivative of the volume equation for cylinders. In order to find the radius when the volume is at a relative maximum, you have to set the equation in terms of volume and radius. We can do this by finding the height in terms of radius using similar triangles. The triangle above the cylinder is proportional to the triangle of the whole cone, so height turns out to be negative 5/3 r plus 10. After replacing the height with this, find v prime and set it equal to 0 to find the radius.
All right, so we have a optimization problem in which we need to enclose a rectangular field with a fence, and that we have 500 feet of fencing material, and that there's a building on one side of the field, so we don't need to fence that side. And so what we need to do is we need to find the biggest area that we can make with our 500 feet of fencing. So what we want is to maximize area, which is a equals x times y. And our constraint is that we have 500 foot of fencing, which is x plus 2y. X plus 2y is the perimeter of this fence. And so what we're going to do is we're going to have to solve this constraint for x. So what we do is we subtract 2y from each side, and we get x equals 500 minus 2y. And with this x, we can substitute that back into our area equation so that we get 500 minus 2y quantity times the y, which is, and when you distribute that all out, it becomes 500y minus 2y squared. And so now that we have to find the largest interval on the largest value that this will make on the interval from 0 to 250. 0 to 250 is our domain, because we could have 250 on both of our y's sides of the fence and not have an x, theoretically. This wouldn't actually make sense, but we're just using closed intervals for this purpose. And so what we do is we're going to take the derivative, which comes out to be 500 minus 4y, and then we set this equal to 0, so 0 equals 500 minus 4y, and then we solve and we get a critical point of 125, and if we plug this into our equation, we'll find out that it's 31,250 feet squared. And because according to the absolute extrema, because it's an absolute extrema because of we're doing it on a closed interval, things like that. And the problem asked for the dimensions, so we're gonna have to plug this back into our x equals 500 minus 2y equation to find that x equals 250. So the dimensions of the field or the fencing is 250 times 125.